Hi everyone, Mr. Shane here to take you through our first lab, the amazing slider of science. And I call it that because you're going to be using a slider and you're going to be looking at science and what is science, and we're going to be exploring the scientific method. Okay, so hopefully you have been able to download the lab and look at it from our Google Classroom assignment. It's called The Amazing Slider of Science. What I'm going to do is go through and kind of talk about the setup of the lab. I'm going to take you through the design of the experiment, part one of the lab. And then we're going to go through and I'm going to give you data. I'm going to take the data with you in part two. Then I'm going to turn you loose to analyze the data by making a graph in part three. Because we're remote, part four is going to be kind of a moot point. We're just going to bypass part four, which is a slider competition where I challenge you to hit a certain distance with the slider. So we're going to move on from that, and then part five will be on your own as well. So today for me with you, it's going to be part one and part two, so that you can get going on parts 3 through 5, excluding part 4, on your own. Okay, so the purpose of the lab. So what I have in front of you here is a normal note card, and the note card here, I'm going to ask you to make a slider. And essentially what I'm going to do is ask you to form up this note card in some way so that you can control its motion. For example, if I just took this note card and pushed it like this, it's a little clunky, it falls over pretty easily, and it doesn't really do a good job of kind of being consistent as far as pushing it is concerned. I can do it any which way, and pushing it really isn't very good control of the motion. But what I can do is I'm going to, in this experiment, I provide 2 meter sticks propped up on one end. This actually, and a marble. This actually helps me control the motion, because if I take the marble and put it on the meter sticks, I can control really how fast that marble goes by setting it at different heights on the meter sticks. Either 10 centimeters, 20 centimeters, or 30 centimeters. I can put it all the way to 90 centimeters. And as it rolls, it picks up speed and rolls rather quickly. So I can control the motion of the marble and thereby control the motion of how fast the slider slides. Now, for the purposes and ease of this lab, I've just given you 2 slider designs, either a wedge shape like you see here, or a cone shape like you see here, kind of swirling the note card into a cone, and then I've taped the end up so that the marble doesn't fall through. If you're using the wedge shape, simply propping the meter sticks up on the books like so does a decent job at catching the marble and then moving it an appropriate distance that you wish to move it. Another thing then, if you use the cone, for example, and I let the marble go, the marble really kind of gets caught in the cone, but it really doesn't even move it. Even if I put the marble back at 90 centimeters and let the marble go, the slider only really slides a little bit. And so if I'm going to use the cone design, I really have to prop up the book like so. If I can get it to prop up here. Prop up the book like so that I can get the marble to move much faster to move that cone. So in the event that we choose a cone for the motion, now with the meter sticks propped up like so, the marble can move past 30 centimeters. And the goal is for us to be able to hit any distance with our slider from 0 to 30 centimeters. And so that's what we're going to be working on. To do that, I'm going to go ahead and just pick the wedge shape. Okay, go ahead and put this down here. And using the wedge shape makes the slider move exactly where you want it. I'm going to show you, the first one I made was this one, and I tested it out and noted that when it moves, the slider kind of did a little bit of turn, so I decided not to use the first one. If you fold the paper the wrong way, the slider is going to turn a different manner. So I made one that was a little tighter and a little bit more centered, and when I actually put the marble on the meter sticks and let it go, the slider slides how I would have it slide. If I flip the paper over, it changes it, so I went and put an arrow on the top of my slider so that I could keep it in the same fashion. Okay. So What our goal here then is, or what the problem is, if we're going to kind of start with number one here, we've designed our experiment here. I've decided that moving a slider is easiest when I use a marble that I can control the speed and motion with. So it says state the problem here for number one in part one of your lab. It says state the problem. In other words, what am I asking you to do? And if you read the document above and kind of look at what I was saying here, that the problem is that the problem is moving the slider in a controlled motion anywhere from 0 to 30 centimeters. So I'll say that in a way that you can write it down. The problem here is controlling the motion of a slider. Simply put, controlling the motion of a slider. Our observations, it says prop up your meter sticks on one side, set your marble down at different heights. We've done that. What happens to the marble when you place it at different heights? We noted that when you place the marble at a lower height, it moves slower, and when you place the marble at a higher height, it moves faster. Simply put, right? Those are simple observations, but it kind of really illustrates the way that the marble behaves. It says form your index card so it will move the marble when the marble hits it. What index card design works best to catch the marble and thus move your slider consistently? Go ahead and write wedge shaped slider, one that has a single fold in the center. Okay, a wedge shaped slider for number three, one that has a single fold in the center. Okay. It says then to state our hypothesis, and I give an example of how we would state that hypothesis in the italics below number 4. This statement of hypothesis, this is an educated guess on how nature operates, on how this slider moves. And my example says, when I prop the 2 meter sticks up at blank centimeters apart, that's an interesting point. When you roll the slider, sometimes the meter sticks can slide. So before each trial, I want to make sure that I'm about a half a centimeter wide with my meter sticks. So you're going to write 0.5 centimeters wide. So it says when I prop the meter sticks at, and then the blank you can write 0.5 centimeters apart at the blank centimeter mark on the textbook. Now, I went ahead and made my centimeter mark 90, so that the meter sticks here go from 0 all the way to 100 centimeters. I'm going to prop the meter sticks up at 90, okay? So you can write 90 in the second blank there. At 90 centimeters mark at the textbook, and instead of textbook, you can cross out textbook and write encyclopedia volume 17. It's our encyclopedia volume 17 that we're using. That sits blank centimeters high off the table. So I'm going to measure how high we're sitting off the table with our volume 17 of our encyclopedia, and it's at about 3.3 centimeters. 3.3 centimeters, so that third blank there, 3.3 centimeters high off the table. The higher I place a marble, which is our steel ball bearing today, on the meter sticks, the farther I will move the paper index card in the shape of a wedge. You're going to fill in the blank with the wedge. So that's essentially the hypothesis. You fill in that out. Now, since you're online, I'm going to have you complete this lab on Cami on the computer. So please, you can print it off and write your answers on a hard copy, or you can just put your answers right into Cami. All right, so as we move forward in the lab. I should have mentioned that earlier. Apologize for that. It says, what are some of the potential problems you may encounter as you attempt to conduct your experiment with this setup? The meter sticks slide apart. The meter sticks could slightly be off in their alignment. The slider might turn this way or that depending on the table inconsistencies. So the slider might change its motion or turn. These are some of the issues that are kind of obvious that would come up as I'm conducting this experiment. If I kind of don't let the ball bearing go just right, or if I adjust how I let go of the ball bearing, it could also have an effect on our experiment. So those are some of the sources of error that we could consider when doing our experiment. Now we need to make some more observations before we continue. And so I'm going to go on to page 2 of the lab, or part 2. It says data, part 2 data. That's page 2 of your lab. And it says test your hypothesis. We're going to go through and test our hypothesis now. We think that we're able to control the slider movement by placing the marble on the rulers, or on the meter sticks that are set up in just the way we had said. And I think we're right. In order to test our hypothesis, it would be good for us to gather a good amount of data so that we know we can move the slider a short distance, a medium distance, and a far distance. So what I'm going to ask you to do is to right off to the side of the starting position of the marble, we're going to write a little S to indicate the sliding distance. What you can see is I have a little S here, and that's sliding distance. I want to try to see how we can move the slider 5 centimeters, 10 centimeters, 15, 20, 25, and 30 centimeters. This is the slider. I want to try to take some observations, make some observations to figure out where I should put my marble in order to make the slider go about 5 centimeters. And once I do that, then I'm going to conduct 3 trials at that particular location. Now I've actually gone through and done it for you, but I'm going to just kind of show you what I mean. All right, so if I want to get the slider to move about 5 centimeters, I would need to find the place where I need to put the marble to do that. When I place the marble at 10 centimeters, for example, the slider is consistently moving about 9 centimeters or so. So let's back it down to 5 centimeters. If I place the marble at 5 centimeters, now my slider is getting close to moving only about 5 centimeters. Okay. So what I'm going to do is, and I have a clean copy of the lab here. So in order to get my slider to move about 5 centimeters, I need to put start my marble on the meter sticks at about 5 centimeters. All right, so that's what I'm going to start with. In order to get my slider to move 10 centimeters, let's try 10. That's just under 10. Let's try 15. That's about 10. In order to get my slider to move about 10 centimeters, I'm going to put the marble at 15 centimeters high on the meter sticks. What I've got for you here is this. I was looking to see how far or where I would need to put the marble in order to approximately get the slider to slide 5 centimeters, 10 centimeters, 15 centimeters, 20, 25, and 30 centimeters. And after making some observations, I figured that 5 centimeters was a good place to put the marble on the meter sticks if I want the slider to move 5 centimeters. 15 centimeters is a good place for me to put the slider if I wanted to move 10 centimeters. 20 centimeters is a great place for me to put the marble on the meter sticks if I want the slider to move 15 centimeters, etc. So that's where I got my starting point. So I have some marble starting positions to try out now. What I'm going to do, I'm going to move the camera so you can see my trials, and I'm going to go ahead and put the marble at 5 centimeters on the meter sticks 3 different times and do trials 1, 2, and 3. I'm going to do the same thing for 15 centimeters, 20 centimeters. I'm going to get all this data filled in. Then I'm going to turn you loose to average it and graph it. Okay, so let me bring the camera over to get a bird's eye view of our sliding trials. 5 centimeters, let's begin. At 5 centimeters, my distance here is about 6 centimeters. I'll go 5.9. So our first trial is 5.9. And don't worry, I'm going to show you the data, a little clip of the data, so you can pause the video and write down your data on your lab. Okay, so let's do the next trial at 5. And when I take and measure that distance, it turns out to be about 5.7 centimeters. Write that down for trial 2. And trial 3 gives me a movement of the slider, and I'm measuring from the back of the slider to start with to the back of the slider at the end, and that's at about 5.9 centimeters. Okay. So as you can see, I have my 5 centimeter marble position. I got 5.9 centimeters, 5.7 centimeters, and 5.9 centimeters. I'm going to add all three of those up and divide by 3 to get my average sliding distance. All right, now I'm going to go speed through and give you the rest of the data here. When you get the rest of the data, you'll be able to average this column out, and then you'll be able to graph the starting marble position over here with the average sliding distance over here, and I'll do a little demonstration to help you out with that. All right. All right, I've got the data here for you from our trials. If you want to go ahead and pause the video and take this data down, or take a picture of it and then add it to your lab data table on Kami, that would be excellent. And then when you get this finished, we'll go ahead and graph the data. All right, so part 3's analysis is to actually graph this data. We're going to put this data on a graph. We're going to take the points and draw a best fit straight line through them, indicating their overall trend. And then we're going to use that trend line in order to tell starting positions of the marble given some distances of sliding. So let's do the graph here first. What we're going to graph is we're going to graph the starting position of the marble versus the average sliding distance. And you're going to have to go through and calculate the average sliding distance for each of these, but I'm going to graph this first point with you. So starting position of marble is 5 centimeters. The average sliding distance is 5.8. So we're going to come to this graph here. Marble starting position is 5 centimeters, so it's going to be right here. And 5.8 was the average sliding distance, so we'll put our point right there at about 5.8. For these average sliding distance, and that's where our first point will lie. Now you're going to get several points on here, and I'm going to go ahead and just put several example points on there so you can kind of see what it might end up looking like. Your points, of course, are going to be different, but I'm going to just throw some on here so that I can explain the next part, and that is the best fit straight line. When drawing a best fit straight line on any kind of lab, you need to consider trying to put the points, equal amount of points on the top as you do the bottom. So for example, if I'm going to make a best fit straight line through these points, I'm going to just kind of like put the ruler in a spot that helps me count 1, 2, 3, 4, 5 points on the top and 4 points on the bottom here. The line would probably go somewhere around here. Again, I count the number of points on the bottom and try to see through the ruler to count the points on top. You can also kind of do something like this to get a general idea. Okay, but then you just go ahead and you're going to draw a line. Now this is not a connect the dots line. This is more of a line showing the trend of the points. Okay, what this does is that if we're missing data, if I ask you to hit a distance of 13 centimeters sliding, we don't have a data point there, but we can go over to our graph and come down and read, and that would be 35 centimeters for the marble starting position. And indeed, I asked that. That's the example here. I say, where should you put your marble in order to move the slider 13 centimeters? You're going to say 35 centimeters based on the graph. Now, this number might be different for you. I just demonstrated this so that you could kind of see the 13 centimeters here, and I also asked 23 centimeters. We didn't get data points for that, but we can come to the graph and look it up and see what the marble starting position would be. For 23, what we do is come up to average sliding distance of 23, move over to our graph here, our graph line, and then drop down to read, and that would be a starting marble position of about 75 centimeters. So we would write 75 for this one. So in part 3, you're going to calculate the average sliding distance, you're going to graph the starting position versus average sliding distance. You're going to use that graph to find the distance here, which is, again, 35 is not the answer, but your line will tell you the answer. All right. Again, we're not going to do part 4 because we're not in class for you to actually challenge. So we're going to cross out part 4. And all you're left with then for this lab is to finish up by completing part 5. So that's it for the lab today. All right, everyone. Well, thanks for joining me for the lab today. I hope you enjoyed it. If you do have any questions as you're working through it, please don't hesitate to ask. Thanks again, and we'll see you next lab.